Hey guys, welcome back to my YouTube channel. So in this video, I'll be doing another example of a joint distribution functions in probability. The joint density function of x and y is given by f of xy is equal to 2 times x times y if x is between 0 and 1 and y is between 0 and 1 and 0 otherwise. Find the probability that x is less than a half and y is greater than a half. This is another example of a joint distribution functions in probability. So in this particular problem, this is an example of a continuous random variable. So let me write down the joint cumulative probability distribution of x and y first. So this would be capital F of xy is equal to the probability that x is less than or equal to x and y is less than or equal to y if x and y are continuous random variables. Then the joint cumulative probability distribution of x and y would be this. And another special case I'll write down is called the joint probability density function of x and y. So it would be lowercase f of xy is equal to its partial derivative of x and y times its joint cumulative probability distribution of x and y, which is capital of x and y. And then there's also the probability that x and y is in C, which is the Cartesian product, is the integral of xy of xy dx dy. So the probability that x is in A and y is in B would just be the integral of B, integral of A, f of x, y, dx, dy. If the function f of xy is the joint probability density function of x and y. So let me write down its joint probability density function. Now let's find the joint density function of x and y and the probability that x is less than a half and y is greater than a half. So let me set up the integral. So this would be 0 to a half to 1 of 2 times x times y dy dx. Now we'll start working with dy first. In other words, the integral of 1/2 to 1, 2 of x y dy. I could pull out a 2x here, but I just prefer leaving it inside the integral. So let me rewrite this. 2 times xy dy. This would just be x times y squared, because remember, it would be a half, so the 2's times 1/2 will cancel. And now let me plug in 1 here. So that would be x. A half squared is just a fourth x. And x minus a fourth x is just 3 over 4x. Now let's work with the integrals for dx. 0 to a half of 3/4 x dx. So the integral of 3/4 x dx is just 3 over 8 x squared. And plugging in f of 1/2, we get half times half is 1/4, so that would be 3 over 32. And f of 0 is just, well, it's obviously just 0. And subtracting these, we would get 3 over 32. So the probability that x is less than a half and y is greater than a half is 3 over 32. And this is another example of a joint distribution function problem in probability.